have done these for you. So I would like everyone to watch till the end, and please do not forget to subscribe my channel, like and share this video. So let's start. Okay, so this is the first question from May-June 2020, variant 1.1. An arithmetic progression has a second term of -14 and a sum to 21 terms of 84. Find the first term and the 21st term of this progression. So this is an arithmetic progression. The first term is missing, the second term is given, and the sum is given. So we know that the formula for the term is this: a plus n minus 1 into d. So you have to use the information given in the question. So since the sum is given, I have used the formula for sum and equal to 84, where a and d are the variables. So I have derived an equation here, as you can see, which is a plus 10d equals 4, by using the formula for sum, which is n by 2 to a plus n minus 1 into d, and n here is 21 because they told that the sum of 21 terms is 84, so n here is 21. And then using the second information, which is the second term, which is -14, where n is 2, you can use this formula a plus n minus 1 into d, where n is 2, and you have another equation which is a plus d equals -14. Then you simultaneously solve them and you get the value of a and d, and using these two values you can easily find out the 21st term, and first term is obviously -16. In the second part it says the geometric progression has a second term of 27p square and a fifth term of p5. So geometric progression, the term formula is this: ar to the power n minus 1. And since t2, which is the second term, and t5, which is the fifth term, are given, I have just used them in the formula, and then I subjected a from both of them and then equaled them to find out the value of r, which is p by 3. Then they told us to find out the sum of infinity. I have just used the formula once again, a by 1 minus r. So this is my answer. And given that the sum of infinity is 81, they have given the value of this. So this equals 81, and then you subject p from there, and we find p, which is 3 over 4. Let's move on to the next one. The first 5 terms of a sequence are given below. So these are 5 terms. So they told you to find out the 20th term. So the very first question that comes to everyone's mind is that, will I is it arithmetic progression or is it geometric progression? So to be honest, I decided that this was geometric progression by seeing the second question, where it said why the sum of infinity exists. So immediately I knew that this is geometric progression, because here is one trick. This sum of infinity, this is always related to geometric progression. It's not related to arithmetic progression. So this was how I decided that yes, this is geometric progression. And another way is, you can find out the differences first. You can see that the differences are not same, so it's not arithmetic progression, but the ratios are same. So it is obviously geometric progression. So then a is 4 and r is second term divided by first term. I found out r, and then I just used the formula ar to the power n minus 1, where n is 20. Then Then in the second part it says why the sum of infinity exists. You have to give the reason. So you have to remember, like always, whenever this question comes up, it means that sum of infinity will exist if the value of r is in between -1 to 1. So this is like a rule, or this is a thing that is related to sum of infinity. Like sum of infinity will always exist if the value of r is in between -1 and 1. And since r is -0.5 and it is in between this value, like -1 to 1, we can say that the sum of infinity exists. Finally, we use the formula for sum of infinity and we find out 8 over 3. Then comes number B. The 10th term of an arithmetic progression is 15 times the second term. So again, according to the question, the 10th term is 15 times the second term. I have just used the formula a plus n minus 1 into d, where n here is 10 and n here is 2. So this is one equation. And then another information is given. The sum of the first 6 terms of the progression is 87. So I have used the formula for sum, where the n is 6 because it says 6 sum of 6 terms. That's equals 87. I got another equation. Then I simultaneously solved them and I found out a and d. So lastly, they told us to find out the value of n, where the nth term is 6990. Again, I have used the formula a plus n minus 1 into d, and here n is the subject this time, and a and d you can easily use this minus 3 and 7, which we found out in requirement A, and then you find out the value of n. In this question, the first 3 terms of an arithmetic progression are minus 4, 8, and 20. So this is an arithmetic progression and the 3 terms are given. So we have to find out the smallest number of terms for which the sum of this arithmetic progression is greater than 2000. So this is my condition. The sum is greater than 2000. So this is my formula. N by 2 to a plus n minus 1 into d is greater than 2000, and a is obviously the first term because the series is given here, and you can find out the difference by subtracting the second like the first term from the second term. This is here, I have done it here. So the difference is 12. So you easily place the values of a and d here, and then you subject n. So n will give you 2 values. One is positive and negative, and obviously n cannot be negative, so you reject this. So your n value is 19.1, and since it's greater, you take the immediate next bigger value, which is 20. The 7th and 9th terms of a geometric progression are 27 and 243. Again, according to the question, I have placed the formulas. T7 is equals to 27, then T9 equals to 243. Then I have subjected a from both of them. Then I have equaled the two a's to find out the ratio, which is 3. Then the 30th term, so T30, again ar to the power n minus 1. So I have a here. So a here is like, you can, since you got r here, you can use any of the formulas where you subjected a, and I have used this one. So I placed the value of r and I got a, and I have kept it in indices form because the question says to give your answer as a power of 3. So I did not simplify, I kept it as a base 3. So a is 1 by 3 cube, and then the difference is 3 here, as you can see, then to the power 29, and then you solve it. Finally, it says explain why the geometric progression has a sum of infinity. So just a while ago I did say that whenever this question comes up, you have to mention that for the sum of infinity, the r should be in between minus 1 to 1. So this is what I have written. So here r is second term divided by the first term, which is sine theta. So you write sine theta is in between minus 1 to 1. So this is a condition you have to write whenever this question comes up related to like sum of infinity. Number 11. The second, 8th, and 44th term of an arithmetic progression forms the first 3 terms of a geometric progression. Now, what does this mean? This means that in arithmetic progression, the second term, whatever you get in the second term, that's the first term for the geometric progression. Then the 8th term of the arithmetic progression is the second term of the geometric progression, and the 44th term of the arithmetic progression is the third term of the geometric progression. So this is what the question means. And in the arithmetic progression, they have already told you that the first term a is 1 and the common difference is positive. They did not mention the common difference, but they just said that it is positive. So accordingly, I have used the formulas. We know that for arithmetic progression, the term formula is this one, and for geometric progression, it's this one. So arithmetic progression, T2, a plus n minus 1 into d, where n is 2. So the first term is a plus d, second term is a plus d, eighth term is 1 plus 7d, and 44th term is this, 1 plus 43d. We are told to find out, we are told to show that the difference is 5. So another information is that, for GP, the first term is 1 plus d, because this is the second term of the arithmetic progression. For the second term of geometric progression, it's this one, 1 plus 7d, because that's the 8th term of the arithmetic progression. And the third term for geometric progression is this one, 1 plus 43d, which is the 44th term of arithmetic progression. So now we can use the formula for common ratio, which is second term divided by the first term. Then you equal them, and then you form an equation, and then you can easily show that d is equals to 5. Finally, you have your d, and in the last one, you are just told to find the sum of the 20 terms. So you just easily use the formula, and you have your d here. N is 20 and a is 1, because 1 is given here. Find the fifth term of the geometric progression. So you are told to find out the fifth term. So we know that the first term of the arithmetic progression, the first term of the geometric progression is the second term of the arithmetic progression, which is 1 plus d, and the second term of the geometric progression is equal to the 8th term of the arithmetic progression, which is 1 plus 7d. So the formula for GP is AR to the power n minus 1, and since this is the first term is equal to 1 plus d, and we do know the value of d, so we can write AR to the power 0 equals to 6, 1 plus 5 equals 6, so a is 6, and here I can substitute the value of a and find out r. So the second term, AR to the power 2 minus 1 is equal to 1 plus 7d, because the second term is equal to the 8th term of the arithmetic progression. So since I have a and r, I can easily use the geometric progression formula to find out the fifth term. This is what I have done. So again, in this question, explain whether or not the sum of infinity exists for this geometric progression, and you already know the answer. This does not exist because r is not in between -1 to 1. So sum of infinity does not exist. Okay, the first term of an arithmetic progression is -5 and the fifth term is 7. Find the sum of the first 40 terms of this progression. So we need to find out the sum. So these are the two formulas, and with the given information, the first term is -5 and the fifth term is 7. So T5 is equals 7. I have used the formula and derived d from here. So now I have a and d. You can easily use the sum formula to get the sum, which is 2140. Finally, a geometric progression has third term of 8 and sixth term of 0.064. So the third term and the sixth term of the geometric progression are given, and we have to find out the sum of infinity, and we know that the formula for sum of infinity is a by 1 minus r. So you need a and you need r. So using these two these two information, we need to find out a and r. So this is what I have done. T3, which is the third term, is given, which is 8. I have just used the formula AR to the power 3 minus 1, which gives me AR square. That will be equal to 8, and I have subtracted a from here. Then again, T6 is given 0.064. Again, I have subtracted a from here. And then by equaling these two a's, I have found out the ratio, which is 1 by 5, and using any one of the formulas, I have used this 8 by r square to find out the value of a, which gives me 200. Now I have my a and r, and then you can easily use the formula for sum of infinity to get 250. Okay, so the first three terms of an arithmetic progression are log 3, 3 log 3, and 5 log 3. So this time the question has the terms in log. So given that the sum of n terms of this progression can be written like this, like the sum can be written like this, and we have to find out the value of n. So again, I have written down the term formula and sum formula. So according to the question, the first term is log 3. So I have written T1 equals to A, which is equals to log 3. T2 is given 3 log 3. So I have used the formula for T2, which is A plus n minus 1 into D. So A here is log 3, n is 2, and difference I do not know. I need to find out the difference. So I have used this formula, which is equal to the second term, which is given 3 log 3. Then I have subjected D, and I have also got D. So I have A and I got D, and we have to show, like we have to find out the value of n, and the sum is given, as 256 log 81. So I have used the formula for sum, which is n by 2. N remains n because we have to subject n. Then A is log 3 and D is 2 log 3, and this is the entire calculation. So you guys can take a screenshot or pause the video to check out the calculation, how I have calculated, and then how I subjected n. So this is the answer for n. Okay, let's move on to the next one. The first three terms of a geometric progression are ln 256, ln 16, and ln 4, and we have to find out the sum of infinity of this progression. So sum of infinity, we know that we need a and we need r, and the term formula is ar to the power n minus 1. So since the first term is given a and the second term is given ln 6, I have used the formula ar to the power 2 minus 1, which is ar equals to ln 16. And from there you can easily subject r because the first term is given. So you can easily subject r from here, and that gives you half. And then finally you can use the formula for sum, which is a by 1 minus r. A is ln 256 because it's here in the question, and then r we just found out 1 by 2, and you just use the formula and then solve it, and you get p as 16. So guys, at this point, I hope you're catching up and you are being able to do the questions on your own. So please do hit the like button if you are watching till now. Okay, so let's move on to, I guess, the second, oh no, sorry, this is our last question for today. So this is from May, June 2022, variant 22. So a geometric progression has first term a and common ratio r where r is greater than 0. So we know since r is greater than 0, it's also greater than 1. The second term of this progression is 8. The sum of the third and fourth term is 160. So there are a lot of information to process here. And we have to show this. So the second term of this progression, so first of all, this is a geometric progression. So the second term is given. So I have again used the formula ar to the power n minus 1. N here is 2. Ar gives us 8. And they told that the third term and the fourth term, their sum is equals to 160. So again, I have used the formula. So ar square plus ar cube is equals to 160. Then since I need the entire expression in r, in terms of r, I need to substitute these a's with r. So what I did from here, I subjected a in terms of r, and I just used this here instead of a. So after I simplify, I easily showed this equation. This equation comes. Finally, we have to find out the value of a. So we know that a here is 8 by r, and before that we need r, so we have to solve this. So I have solved this, and since r comes in negative, we have to reject the negative r, because in the question it says it is greater than 0. It has to be greater than 0. So we cannot accept -5. So r is 4, and finally we can just place this r here, 8 by r. So 8 by r, and a gives us 2. So this is the last part. An arithmetic progression has first term p and common difference 2. The qth term of this progression is 14. A different arithmetic progression has first term p and common difference 4, and the sum of the first qth term of this progression is 168. So find the values of p and q. So again, this is an arithmetic progression, and these are the formulas for the term and sum. So for the first series, the first term is p and the difference is 2, and the sum of the qth term is 14. So here I have used the formula for the qth term of this, not the sum. The qth term of this is 14. So tq, I have to find the term tq. So a plus n minus 1 into d, and n here is q because it's the qth term. That's equals to 14. A is p and d is 2. Here I get one equation. And then here for the second arithmetic progression, the first term is p and the difference is now is 4, and the sum is given now. So sum of the qth term. So I have used the formula for sum here. So where n, the value of n is q, as you can see here, like q by 2, which is n by 2, 2a plus n minus 1 into d. A is p and n is q, and d is 4. So I have derived another equation here. So in order to solve p and q, I have used the substitution method. I substituted p from here, like I subjected p from here and substituted the value of p in this equation, as you can see here. Then it finally gives me the value of p to be -8, and then I can easily use them in any one of the equations and find out the value of q. The equation was in terms of q. I found out q first, and then I replaced q in the here in this equation to find out p. So this is my p and q. So this was for today, and please do wait for part 2, where I'll be explaining rest of the sums on arithmetic progression and geometric progression.